Good morning, students. Today we'll do diffraction due to single slit, and I explained you diffraction in my previous class. There we did that light travels in a straight line, and whenever an object comes in the path of light, it casts the shadow. And we already did that light also bends and spreads at the corners of the slit or obstacle, and then it spreads in the shadow region. So the shadow region is not completely dark. There must be some light in the shadow region, and this light is due to bending and spreading of light at the corners of the obstacle, which we called as diffraction. And beta, we already did that this thing happen only, this bending and spreading of light takes place only if the size of obstacle is comparable with the wavelength of light. If this condition satisfied, only then we observe the diffraction phenomena. And in diffraction phenomena, as I already told you, like interference, we also observe the pattern on the screen. The pattern which we observe on the screen is of maxima and the minimas, and this thing we will study in our today's lecture, that what are the conditions which should be satisfied, and then we observe the maxima and the minima pattern on the screen. In the interference, when we did interference, we use the term constructive and destructive interference, and we use the term fringes. We see the fringes or bands on the screen. In the diffraction, we use the term maxima and the minimas. Okay, beta. Now, beta, before starting our today's lecture, diffraction due to single slit, I just want to explain you this diffraction by Huygens theory also, so that the picture of diffraction will be clear to you in terms of waves also. See, you already did the Huygens principle, and we know the as per the Huygens principle that each point on, if there is a wavefront, then each point on wavefront will act as a source of new disturbances. And if I draw a tangent to it, then I'll get a new envelope. Then this envelope, not new envelope, I get an envelope, and this envelope gives me the position of new wavefront. This thing what we did in Huygens principle, that how light travels in the form of wave. Now see beta, to explain here diffraction, let me suppose this is my slit. I'm showing you the wider slit so that the diagram should be neat and the picture should be clear to all of you. Otherwise, the slit which we consider here, it should be very narrow. It should be of this much. See beta, suppose the rays falls on the slit AB. When the rays falls on the slit, this is my plane wavefront. So when the plane wavefront strikes on the slit AB, then what will happen? Then each point on this slit, each point, suppose this is 1, 2, 3, 4, 5. I'm showing only 5. There are a number of points you can take. Each point on the slit will become a source of new disturbance. Each point will become a source of new disturbance, and these disturbances are called the secondary wavelets, which spreads in all direction. So from point 2, the secondary wavelets or new disturbances will spread. From point 4, the secondary wavelets will spread and they move in the forward direction. If I draw the envelope, I get the position of the new wavefront. So if I consider point here, the waves will spread like this. If I consider a point here, the waves will spread like this. So the waves are spreading in the forward direction. As beta, all of you know, the light rays direction is always perpendicular to the wavefront or the wavelet. If I draw, this is perpendicular to the wavefront. So it means the waves if I draw, this is are the disturbances which are emitting from my point 1, and if I draw the rays, if I draw the tangent, then it gives me the position of new wavefront. Now if I draw the rays, and these rays are perpendicular to this wavefront, means these light rays are spreading in all directions. Similarly, from point 2, from point 3, these rays, light rays are spreading in all direction. So beta, due to the spreading of the waves, as you clearly see here, the waves are spreading. Due to the spreading of the waves on the screen, in the shadow region we see the light. If the waves are not spreading, then the shadow region is confined here. This should be the shadow region. This point should be the shadow region or the dark region. But what is happening here? The waves are spreading. Due to the spreading of the waves, we also see light here. We also see light here. Now, is it clear how we see the light in the shadow region? And one more thing I want to tell you beta here, that the wavefront which is falling on this slit AB, you can clearly see it is a plane wavefront, and the wavefront which we get after falling on the slit AB is spherical wavefront. So the wavefront which is falling and we are getting is different. Actually, the size of the slit is very narrow. As I already told you, it should be very narrow. I show you the wider one only to give you the clear picture of the spreading of the waves. That's why I draw a very wider one. Otherwise, the slit is very narrow, and when the wavefront, plane wavefront fall on this narrow slit, it will act as a point source, and then all the particles are oscillating, which get emitted or which emit the spherical wavefront. So the shape of the wavefront what we get after falling on the slit is spherical. Beta, this is diffraction according to the explanation according to the Huygens principle. So from this I think the picture is clear to all of you that in diffraction the waves are emitting. This is my single wavefront. Suppose this is my single wavefront. The diagram is not that neat. This is single wavefront, and from the single wavefront the waves are emitting, the waves are spreading. These waves will superimpose, to form a pattern on the screen. So in diffraction, what is happening when I use the word superimpose? When these waves are superimposing, mean what is happening? Interference is happening in diffraction. But even when we did the Young's double slit experiment in our last to last lectures, even that time when interference was taking place, diffraction was also there, but the interference was more dominant. So when the diffraction is taking place, the waves are superimposing and they form a pattern on the screen. The difference is when we did the interference, the waves which were superimposing, they were emitting from two coherent sources. From the two coherent sources, the waves which were superimposing, they were emitting from two different sources, although the sources are coherent. Here in diffraction, the waves which are superimposing, they are emitting from the same points of the different points of the same wavefront. Means in diffraction, which phenomena is taking place? This interference is taking place. So the condition of constructive interference and destructive interference should be clear to all of you. I think beta, I should stop here. Otherwise, the lecture will become very lengthy. We will find the conditions of maxima or minima in diffraction in our next lecture. otherwise if I'll drive here it will become very lengthy. So I think I should stop here, and the picture is clear to all of you how we see a light in the shadow region, because what is happening here, the light rays, because light is in the form of waves, so it is bending, and after bending light is spreading. And one more thing, when light spreads, when I say the words the light is spreading, means the light is deviating from its straight path. That's why it is spreading everywhere. It is deviating from the straight path, it is spreading. When light is spreading, then it must spread at some angle. That angle of spreading is called as diffraction angle, and we represented it by theta. Now I think these things are clear to all of you, and we will derive the conditions for maxima or minima in our next lecture. Maxima and minima are the same, like we used to say the constructive and the destructive interference, we say the bright band and the dark bands. In the diffraction we use the terms maxima and the minima. Okay beta, thank you for today's lecture. I think I should stop here. This much is enough for today's lecture. Thanks beta.